Now, please, you have to subscribe. Like I was saying before in my previous videos on calculus. Now, if you look at this, like I said, I wanted to show us the standard table for differentiations. Standard table for differentiations. When they call this standard, that means those things are where they are just like that, they are fixed. Now, then if y is x raised to power n, like what I showed on the formula for calculus, general principles of differentiations. So we bring this n to multiply this, and n minus 1 give us this. All of these things have a way of proving them. Now, exponential x, this means exponential x. Anytime you are given exponential x in calculus, it's always equal back, it's still the same. The answer is always the same as exponential x. So when we start going to that stage by stage, you understand every set of things you see here. When you see something like this, a raised to power x also means log. It means log. And when you want to differentiate it, that means a raised to power x ln a, because it's in the form of logarithms. I'll show you when we get there. Sin x in calculus, the y-ds of sin x is always cos x. Now, for those of you that you have not watched it, I've done this one on my link, step by step way of proving sin x to cos x. Just check, you will see that I've done this one before. How to prove sin x to be cos x. I've done that one. And the proving of cos x is minus sin x. I've done this also on how to prove cos x to minus sin x. I've done it. You can just take your time and watch. And before you can watch and get it clearly, make sure you watch my additional formula, product formula in trigonometry. We are meant to learn. We are bound to learn. We need to learn. Now, the tan x, that one is sec square x. I've done that one in my short videos, but I may actually beat again, no problem. But I've done it in on my short, one of my shorts. I've done that. And sec x is the y-ds of sec x is sec x tan x. The y-ds of cosec x, it is minus cosec x cot x. The y-ds of cot x, it is minus cosec square x. The y-ds of arc sin x, inverse of sin x, is 1 all over root of 1 minus s squared. The y-ds of sine and cos inverse of x, cos inverse of x, it is minus 1 all over square root of 1 minus s squared. And the y-ds, the remaining, is here. The y-ds of tan inverse of x is minus 1 all over 1 plus s squared. And the y-ds of sec inverse of x, it is 1 all over x root of s squared minus 1. And the y-ds of cosec inverse of x, that is minus 1 all over x root of s squared minus 1. And the y-ds of cot x, that is minus 1 all over 1 plus s squared. These are the standard table for calculus, differentiations. But I would like to tell you this. We don't need to cram all these things. Do we need to cram it? No, we don't need to cram it. What we need to know is how to prove it. And I'm going to show you how to prove all of them one after the other. What you just need is that you just follow. Just make sure you follow these videos step by step. Now, but for today and now, I'm going to show you. But before we even learn how to prove them, I'll proceed on calculus proper. You have to know the formula we used in calculus, the rules that will follow while differentiating. And what are the rules? rules. Now, number one, we have what we called product rule. We have product rules of differentiating calculus. And product rules is always like this: y equals to uv. Y equals to uv. Y equals to uv. And the formula is y equals to u dv dx plus v du dx. Now, let me ask you, when you see a questions in calculus, in differentiations, they will not tell you that you are using product rule or you are using quotient rule or you are using any rule. It's you that you have to know the rules that you are going to take or use for that particular questions. Now, look at this one. You can only use these rules when you have a questions that stay like this. Two things stay beside each other. You will know. That's why I put this one forward. Y equals to uv. You know that, okay, I'm using product rule for this. Now we have a rule that we call quotient rule. That we call quotient rule. That one is y equals to u all over v. Y equals to u all over v. That means y equals to v du dx minus u dv dx all over v squared. That's the formula for that. We have to memorize it, we have to know it. And this is quotient rule. When will I use it? When you have something in divisional form. In the case whereby you have a question, you have numerator and denominator, you are going to employ this guy, quotient rule. And mind you, this one must always be in the front, v du ds. Don't say, in the product rule, you can write whether u dv ds or v du ds in the front or the back. You can put it anywhere because it is a plus sign we use in product rule. But in quotient rule, whereby we use minus, you are not permitted to put u dv ds in the front. You will miss it. So you can only use v du ds minus u dv ds all over v squared. That is for the quotient rule. Now we have composite rule. We have the composite rule. Composite rule. We also call it function of a function. Function of a function. You can even call it chain rule. Now, the formula, how do you come about that one? The y dx for that one, it is dy du multiplied by du dx. I'll show you how to use that one. We are differentiating two things. That's why we call it composite. So we use this formula. Now, before I will start now showing you how to derive that thing, let us use this method, this formula, to do like 2 or 3 or 4 questions that will help us very well. Okay?